Hello everyone. Today I'm going to present our paper. Title is Adaptive Dialog Policy Learning with Hindsight and User Modeling. My name is Yan Cao, and this work is in collaboration with Keting from Baidu, Xiaoping Chen from USTC, and Shiqi Zhang from SUNY Binghamton. And I'm currently a master student. I will present this work to you. Nowadays, we can see many different types of dialogue systems, and I'm giving a few of examples over here. For instance, Amazon is developing the Alexa system that can help us get information about weather, news, and making orders online. The bottom left is Cortana from Microsoft. The middle one is Xiaoping from Baidu. We can see many such examples in our daily life. A typical dialogue system includes a few components. For stitching information of our language understanding, an output of language understanding is passed to Dialog Management. An output of Dialog Management is used for language generation to directly interact with human users. And in this work, we focus on dialog management. It can be implemented using the following methods, including rule-based method, statistical method, and machine learning-based method. And in this talk, we are particularly interested in deep reinforcement learning-based method. Dialog policy learning can be modeled as a reinforcement learning problem. And there are at least two types of dialogue systems. One is called chit-chat system. The other one is called task completion dialogue system, or sometimes people call it goal-oriented dialogue system. We are interested in task completion dialogue systems. We are using deep queue network as RL framework to compute action policy for our task completion dialogue system. People have developed methods to use RL methods for dialog policy learning. However, RL-based dialog policy learning has its unique challenges. For instance, when the dialog policy is of poor quality, user experience with such dialog policies can be very low. Another challenge is that interacting with real human users produces very high costs. The above two observations motivated the development of high-efficiency dialog policy learning methods. And in this work, we developed a method called LHUA, Learning with Hindsight, User Modeling, and Adaptation. This work is not the first on improving dialog policy learning efficiency. There are already a few methods. For instance, Zhang, and Chen have developed HER-based dialog policy learning with hindsight experience replay. Peng et al. Propose deep DynaQ, namely DDQ, integrating planning for task completion dialog policy learning. Then, Su et al. Incorporate a discriminator in DDQ. Later, we compare our work LHUA with the above three baselines. The experiment platform is TC-Bot, presented by Li in 2017. Let's go into LHUA and see it from the inside. The key part of it is the dialog agent. It learns dialog policy from directly interacting with real users while reinforcement learning. Besides real users for generating real experience, we introduce a simulated user for generating simulated dialog experience. This user model learns to capture real users' interactive behaviors with our dialog agent and dresses up as a user to interact with the dialog agent. In practice, there is a selection problem. At a particular time, From which source should the agent obtain dialogue experience for policy learning? So we propose an adaptive coordinator. It learns a meta policy for selecting between real and simulated users, depending on the current learning phrase. Meanwhile, the samples from both real and simulated users are passed to the Hindsight manager. It can synthesize successful, though not real, dialogue samples. So far, we obtain an overview of LHUA. This research focuses on dialogue policy learning, and this framework is unique in ways that our dialogue agent is simultaneously learning from real users, simulated users, while at the same time learning from Hindsight experience. To be more specific, simulated user is formed as a multitask perceptron. In each term, the input includes current dialogue state S and the last dialogue agent action A, and it outputs next dialogue state S prime and as well as reward R. It learns from experience of interacting with real users. Our adaptive coordinator is modeled as reinforcement learning. It learns a meta policy to choose action K. The value of K determines how many dialogues are conducted with simulated users. When it comes to Hindsight Manager, the K part of it is based on our previous work in 2019. I show you an example for booking movie tickets to demonstrate how to convert unsuccessful dialogue samples into successful ones. We can see that head segments in blue color from both failed and successful dialogue samples satisfy the same constraints, including start time, city, and movie name. Then we consider whether the right one in blue color can be replaced by the left one. The dialogue segment in blue color on the left can be stitched with one in green color on the right, only if their connecting dialogue states are similar enough. Now the newly generated successful dialogue achieves the goal that is originally from the dialogue on the right, but they have different flows. So the Hindsight manager generates new successful dialogues by stitching two suitable dialogue segments. Before showing experimental results, we briefly introduce a dialogue simulation platform used in our experiment. TC Board is proposed by Li et al. In 2017, and it is a realistic movie ticket booking platform. With the help of it, we can obtain meaningful results. The main experimental result is shown in this slide. The y-axis is success rate during learning phase. DDQ and D3Q supports learning from real users and simulated users, but DDQ does not support adaptation. Neither DDQ nor D3Q supports learning from Hindsight experiences. And SHER, Stitching-Based Hindsight Experience Replay from 2019. This previous work supports learning from Hindsight experiences, but does not support learning from simulated users. Our work, LHUA, for the first time enables dialogue agents to adaptively learn with Hindsight from both simulated and real users. We see that LHUA outperformed 3 baselines from the literature. To look into our method, LHUA, we are interested in which components of that LHUA is contributing to the success of the whole framework. So we compared LHUA that support learning from real users, simulated users, and Hindsight with a few its ablations. That includes DQN, DDQ, SHER, and LHU. Here we want to emphasize that both LHU and LHUA are new methods developed in this research. And we can say LHU and LHUA perform better than its ablations, which further justify that all components of LHUA are important and all contributing to the success of the whole framework. Let me make a brief summary. We have developed an algorithm called LHUA, Learning with Hindsight, User Modeling, and Adaptation, for simple, efficient dialogue policy learning. This is the first work that enables dialogue agents to adaptively learn with hindsight from both simulated and real users. In future, we will further evaluate and analyze our LHUA. That's all for my presentation. Thank you for watching this video.